Hi dears, this is a video to solve application 3. Let's start. I have to introduce a note about the circle. Consider a circle in a coordinate system of this center which has coordinate A and B and a certain radius r. The equation of a circle is x minus a all of its square plus y minus b all of its square equal to r square. Please keep into your mind this equation, where a and b are the coordinates of the center and r is the radius of the circle. Application 1 said, the position vector of a moving particle p is given as function of time r equal 4 cosine 2t plus 4 sine 2t along j. This is x and this is y as we are used to do. First part, verify that the trajectory is circular with center O and radius r to be determined. I have to find the parametric equation first. From here, I can find x, and I will isolate the cosine in order to get x over 4. And from here, I can get y, and I isolate the sine in order to get y over 4. Now, don't forget Pythagoras that said cosine square plus sine square of the same angle equal 1. I will apply it here. X square over 16 plus y square over 16 equal 1. By making a cross multiplication, I will get x squared plus y squared equals 16, which is very similar to an equation of the circle with a here. By comparison, a is 0, and b with comparison with y squared is 0. And this 16 is r squared. This can prove that the motion of p is a circle. This circle has a center, 0, 0, which is the origin, and a radius of 4. Done. Part 1. Part 2. Part 2, he said, locate on the adjacent figure. He gave me the figure here as a given, and he is showing me that the motion is a circle. And at here, the time t0 started at point P. He said, locate on the figure the position of P at t1 equal pi over 4 second, and t2 equal pi over 4 second. I will tell you a note here. Please use pi outside the sine and cosine as outside, okay? As pi equal to 3.14 or the one existed on your calculator. Okay? This is outside the trigonometry. Outside sine and cosine. And cosine. I'm sorry for bad handwriting. Outside sine and cosine and tangent and cotangent and whatever. Okay? But you have to use it as pi, okay, which is 180 degree if you are using your calculator in degree, okay? Inside. Please put this note aside for you to make things easier on your calculator. I will proceed. He said, he said in this part that I have to calculate R1 at T1 equal pi over 4. I have to substitute pi over 4 inside this cosine. Pi over 4 inside this cosine will be, and here don't forget that you have 2t. So it will be, let me write it. 2t in this case will be 2 multiplied by pi over 4. And it is pi over 2. And pi over 2, if I want to use it inside the cosine and inside the sine, I have to use it by a degree. So it's 180 divided by 2 degree, which it will be 90 degree. What will happen to cosine 90? Cosine 90 on the calculator is 0, and sine 90 is 1. I will proceed. R1 will be 4 along j in meter, and R2 will be minus 4 along I in meter. Check your calculations, please. He asked me to locate. That's how I locate them. I will locate R1 here, okay, as shown on the diagram. I'm just ensuring that you are seeing it. And this is R2, which is minus 4, sorry, which is minus 4 as shown on the diagram. Sorry again, this is electronic writing. Let's go to the next part. Now in this part, he asked me to calculate the actual distance. What did he mean by actual distance? Covered by P between t equal to 0 and t equal to pi over 2. Let me check my figure. T equal to 0, I am here. Okay, I am at this point. And don't forget that the object is in rotation. Where is t equal to pi over 2? I have to remember my position vectors, which I locate them already. R0, which is equal to 4 along I, and R2, which is equal to minus 4 along I, which means finally I would be here. So this is my actual distance, in fact. If this is my actual distance, I have to calculate it using cross multiplication or using cross multiplication. For example, I will show it to you. The perimeter of the total circle is 2 pi r. Okay, this is the total circle, 360 degrees. But what about this section, which is only 180? I will place 180 here and make a cross multiplication, and this is the distance x. X would be, don't forget in a cross multiplication, the nearer, and then divided by the diagonal. 2 pi r times 180 degree divided by 360, you will get, sorry, you will get it as pi r simply. Somebody know directly that it is r. If you know directly that it is r, this is good, which means that the actual distance is only pi r, which is 4 pi, which is a 12.56 meter. Part 4. Part 4, he asked me to determine the displacement vector, delta r. Okay, to determine the displacement vector and its magnitude between t0 and t2. He said take radical 2 to be 1.4. I will start solving. R0, which was 4, and R2, which was minus 4, sure along I, delta R has a formula. It's R2 minus R0 minus 4I. Minus 4I, I get minus 8I in meters. And its magnitude by using Pythagoras, or simply since it's one-dimensional, it's 8 meters. Part 5. He said compare the actual distance and delta R and conclude. The actual distance was given with us to be 12.56 and the magnitude of delta R is 8. We are sure that any curvilinear distance, okay, any curvilinear distance is bigger than the direct distance between 2 points. That is, they are not equal. And the actual is greater than delta R. In two-dimensional motions, the distance covered is different from the magnitude of the displacement vector. 6. He said, calculate the average velocity between t0 and pi over 2. The average velocity have a definition. Sorry, the average speed, not velocity. Okay? The average speed is the direct distance or the actual distance divided by the duration. The actual distance was given by me 4 pi. I left it as 4 pi in order for pi and pi cancel. Divided by delta t, which is t final minus t initial. Pi with pi cancel and I proceed calculation. I get 8 meter per second. Never mind about substituting their actual values, okay? This as a 3.4 and this as 12.56 as I remember. Number 7, he said calculate the average velocity between t0 and t2. Deduce its magnitude. The average velocity has a formula. It's delta r divided by delta t. Delta r was calculated as minus 8I, and delta t is t final minus t initial. I get minus 5.1I. Its magnitude, you can apply Pythagoras, or you can simply, since it's one dimension, so it's 5.1 meter per second. 8, he said compare V average, which is the speed, okay, not this, and the magnitude of the velocity. V average was calculated, and it's different from the magnitude of the velocity. It was bigger. This is my conclusion, that in two-dimensional motion, the average speed is different from the magnitude of the average velocity vectors. Thank you, dears.